In this video, I'm gonna show you a golden investment. We will use Fibonacci sequence to determine how many rabbits we can produce in just 2 years. Join us. I'm Memoize Implementation from Algorithmic Academy. Let's start rabbit production. Consider that at the beginning of the time, we have 2 cute newborn rabbits like this. So how many pairs of rabbits we have currently? Just 1. After 1 month, we have 2 adult rabbits that can attend to order, and the storks will find for them 2 new rabbits. So now, after end of 2 months, start of the 3rd month, we have 2 adult rabbits and 2 newborn rabbits. So totally 2 pairs of rabbits. So you can see that after another month, the old adult will come with a new pair of rabbits, and also our previously newborn rabbits are now adults. Let's see what happens after 4 months. Now, number of pairs of rabbits is 5 because we had 2 pairs that generated 2 pairs actually ordered from stores, and also we had a newborn pair that is now an adult pair of rabbits. So question here is, after a year, like the start of the 13th month, how many rabbits do we have? Actually, how many pairs of rabbits do we have? So you can pause the video right here, think about this problem, and come back. This is a huge number. We have 144 pairs of rabbits just after a year, which is great. You can see a lot of adult rabbits and also a lot of newborn rabbits. So now we need to see how we can calculate this. So let's define Fn to be number of pairs at the end of the nth month. Like F0 is just 1 because at the beginning of the time we have 1 pair. F1 is again 1, then F2 is 2 because after 2 months we have 2 pairs of rabbits, right? So now let me write down that Fn is actually number of adults plus number of newborns. So now let's write down how many adults and how many newborns we have. So for adults, let's say the number of adults at the end of nth month is actually the total number of pairs we had after n-1 month, right? Because those pairs were either adult or newborn, but anyway, after 1 month, we are sure that they are all adults. But now let's count newborns. For counting newborns, we need to first count how many adults we have. So from the adults at the end of the n-1 months, for each of them, we will see a new pair of newborn, right? So now, answer me, how many adults we have after n-1 month? It's equal to Fn-2. So we lead to the following formula. Fn is equal to Fn-1 plus Fn-2. So that is the popular Fibonacci sequence. And the base cases are F0 and F1, which are 1, and you can go from that like 1, 1, 2, 3, 5, 8, 13, 21, and so on. And finally, after 12 months, just 1 year, you will have 144 number of pairs of rabbits So I strongly recommend you to invest on rabbits because after just 2 years, you will have more than
Wow.
46,000 pairs of rabbits. So let me start implementing these functions. First method we are gonna implement is a very basic way to implement Fibonacci sequence, which is doing it recursively. So let's implement. I'm gonna define a function f, which gets parameter n and returns Fibonacci of n. So if n is 0 or n is 1, just return 1. Otherwise, return fn minus 1 plus fn minus 2, and then like print Fibonacci of like 10. And let's run 89, which is correct. So the second way I'm gonna implement this function is gonna be using dynamic programming. So for doing it with dynamic programming, I'm gonna define an array like let's say of size 11, and then I fill the first two elements of the array by 1, and then let's do a for loop and set f of I is fi minus 1 plus fi minus 2, and finally print f10. And again, what we see is 89. So in this new code, I just replaced the recursive function with this array. If you know how to determine time complexity of algorithms, let me tell you that our previous algorithm was actually exponential. The number of operations is equal to fn itself, and this code, this new dynamic programming code, time complexity of it is on. So it's like if we are gonna calculate it for n, we are going to do something like n operations overall. And although we can calculate it very easily just using a for loop, so let me show you how we can implement Fibonacci using just a for loop and two variables. So I will set a to 1 and b to 1. These two are gonna be f0 and f1. Now I do a for loop and I start from 2 and I go to 10, and every time I want to calculate fi, so calculating fi, so I define c, which is fi, and it's a plus b. And finally, what I do is setting a to b and then b to c, because we are gonna shift n to the next one and we don't need a at all. We write b into a, and then we write c to b, and finally I print b, and here again we have 89. Finally, I'm gonna show you how you can solve Fibonacci sequence using that recursive function but with Memoize. So let's define f again, fn, and then let's say if n is less than 2, return 1, and we can use a map here or an array or everything you want. Name it cache. If cache dot count n, just return the cached number. Otherwise, calculate the Fibonacci number, write it into the cache array to remember next times, and that's it. So I can print f10 here again, which is equal to 89. So let me describe how this function works. So function a works like this. First of all, if it's just the obvious case, base case is that's it. Otherwise, I have a cache array that once I calculate some Fibonacci number, I write it into the cache array, and afterward, I will go use it if I see this n again. So consider this case. I want to calculate F10, right? For calculating that, I need F9 and F8. And F9 needs F8 and F7. And F8 needs F7 and F6. But you're clearly seeing here is F8 is calculating 2 times. And F7 is calculating 2 times here. And also F7 will be calculated again in calculating F8. So we are calculating the same thing a lot of times. A lot of times. Which makes it almost impossible to calculate Fibonacci number for big integers, even like for 100 or something like that. So to make it possible, although that we can use dynamic programming, or we can use that for loop, we can also use Memoize. And it works like this. When I calculate Fibonacci number for n once, I just return it next time. So this way, I will avoid multiple calculation per single n. In the next videos, I will show you an amazing way to calculate Fibonacci numbers for super huge numbers in very good time complexity. And also, I will show you how you can calculate Fibonacci number using matrix exponentiation. And thank you for joining us. Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.